everyone, and welcome to the one and only lesson for today. We are going to be talking about something called composite functions. And hopefully you've heard of that before, but if you haven't heard of that, we have a great visual example of that. Because a composite function is effectively just putting a function inside of a function. So just like this picture right here, where we have multiple dolls inside of each other, we will be dealing with a function inside of a function. So when we want to represent composite functions, we have two ways to do that. What's on the left is the most obvious looking one, even though it's actually not the most commonly used one, where we have g of x clearly inside an f, right? So it's g of x inside of f of x. And then on the right side is a more common one, where you have f of g of x, and it's a bit hard to figure out what's going on here with the little open circle right here, but what I recommend is just start with what's closest to x, so g of x. That's what's on the inside, and then f of x happens. So I think the best way to fully understand this is to just take a look at some examples. So let's go ahead and do that. So here's the first example, where we have f of x equals x squared minus 10x, and g of x equals 2x minus 9, and our goal is to find f of g of 2. So first off, you will always be told what f of x and g of x is. If you are not, then you cannot find the value, right? You can't solve it. So because g is next to 2, it's next to the small, that right there, we're going to find g of 2 first. That is our inner function. So I take g of x equals 2x minus 9 and replace the x's with 2. So now it's g of 2 equals 2 times 2 minus 9. 2 times 2 is 4. And then we have 4 minus 9, which is negative 5. So we know that the first part here, g of 2, is equal to negative 5. Now the next question is, how do we find the full f of g of 2? What I'm going to do is I'm going to take my answer, negative 5, and put it into the outer function, f. So now I'm going to have f of negative 5 and equals, all the x's are replaced with negative 5, so now it's negative 5 squared minus 10 times negative 5. So I'm going to solve this slowly. Negative 5 squared is 25. Then we have minus 10 times negative 5 is positive 50. And now we just add them together and we get 75. And that's our answer for this example right here. Notice once again, it's just really a two-step problem where you solve the inner function, take your answer, and put it into the outer function. Let's do one more example though. Let's use the exact same functions, but let's swap the order and replace 2 with 6. Why not? Why not? So let's find f of 6, because that's the inner function now, not g, but f. So I'm going to replace all these x's with 6's, and now I'm going to slowly solve it. So in this case, we're going to have 6 squared, that's 6 times 6, which is 36, minus 10 times 6, minus 60. Now that we have that, we just do 36 minus 60, and we get a negative 24. So that's what f of 6 is. Now remember, the next step is, let's take our answer and put it into the outer function. In this case, it's g. So I'm going to find g of negative 24 equals 2 times, but instead of x, I'm going to have a negative 24 minus 9. So 2 times negative 24 is negative 48. Subtracting 9 is negative 57. And that's our answer, guys. And that's all we're working on for the next class, just so you get used to this idea of composite functions. If you have any questions, feel free to email me or ask them in class. Otherwise, make sure you do your homework on time, and you have a great day. Bye.